Hey y'all, Mr. Howard back. It's been a while. I decided to do another video because I know that in the previous that I posted, my technology was a little bit out of place. So it was hard for me to write the information out as needed. So I decided to type this one out, but give you another example. But this is what I need for you to do. Work the problems with me. To learn how to write a good report, you need to write the problems. You need to do the problem with me. Do not watch the video first and not watch the problem. You're not going to understand the way to fully get it. Work the problems out first. Then, then, play a video. So, when you get to the experiment, which you're going to see momentarily, pause the video first. Pause the video first. Pause it. All right? And then after you pause it, I want you to read the problem. Read it. And then after that, play it. So therefore you could, see how I read it and what information I took. Then from there, pause it again. And you need to do the following. Put the table in decimals. Don't watch the video. Well, that part of the video, pause it. Go to decimals. Put the information in decimals. Talk about the relationship in terms of the experiment. And don't forget to give me my R. Then from there, give me my equation that I need. Then describe the slope of the equation in regards to the experiment. And then I need for you to answer some questions when you get to that part. So when you play new parts of this video, when you see something else new, pause it and just try it out on your own. So do not watch the video and not work this out with me. Because if you just watch it and just seeing what I'm doing, you're not practicing it, I can't help you. All right, y'all. So here's the experiment that went on with Mr. Ernesto. Ernesto wants to figure out how long it usually takes to get through a supermarket checkout line. For several weeks, he observed the checkout lines he waited in. He counted how many people were ahead of him in each line he joined, X, and how many minutes it took him to get to the following line, Y. So the reason why I read this to you guys because it's very essential to know the experiment, know what the experiment is talking about. So we talked about it. Now we have to highlight what's essential. All right. So when I'm reading through all of this, the pieces that speak out to me is when referring to X and Y, the independent being X and dependent variable being Y. I underline how many people were ahead of him at each line he joined. That's my X information. And then for my Y, how many minutes did it take him to get to the front of the line? So again, I'm just highlighting what's important so I can understand what this table is talking about. Because that's essential. You have to be able to read, know what's important so you could get ready to talk and analyze the situation from there. All right, guys, I got to describe the relationship. That's the first thing I got to do. Again, the relationship, as we know it, is talking about the correlation coefficient. Okay, and remember, anything that's 0.5 and above is considered to be strong. But I know in class I told you that anything that's under 0.6 is weak. So just to be safe, do this. Anything under 0.6 for your correlation coefficient is weak. Again, anything under 0.6 is considered to be weak. That's going to help us get this. All right. So notice how I got the information that I highlighted on here again. And the reason why I got this out here because this is going to help me make a good statement of what's going on. So again, looking at my decimals, I get R to be 0.988, in which we know since it's close to 1, since it's close to positive 1, it's a strong relationship, and since it's a positive number, it's a positive strong relationship. However, that's not good enough. You have to take the step further and explain. And this is a good response. The relationship between people on the line and minute take, again, I'm pretty much taking information from here and having that discussion about it. So that's where my information is coming from. So again, I'm taking this information, and since it's a strong relationship, I just talked about it being a strong relationship. And then I did one more thing, but let me go ahead and read my statement. The relationship between people in line and minute it takes is a strong relationship. The more people, the more minute it takes. So again, this is just coming from here, and that's just me writing it just a short way. You could write things differently because on your test, of course, you gotta be able to show some type of originality how you interpret it. You could write it like this, or you could say the relationship between how many people are ahead of Ernesto and how many minutes it takes for Ernesto to get in front of the line. It's a strong relationship. You could say that too. But to nail the case, the ice on the cake to get more answers, you have to explain this. And let me explain what this is. So this talks about the correlation coefficient being positive. So it looks like that. So that means that the more people, and I'm sorry for my bad handwriting. So the more people, the longer it takes. And again, I do have technical issues going on, so I am writing with my fingers, so that's why the handwriting looks a little bit sloppy. But again, you're going to realize, in terms of the correlation coefficient, you're going to realize that that's going to also help us a little bit dealing with our slope. Because you know we have to talk about that too. So you have successfully talked about the correlation coefficient. And again, you see how I'm taking this important information? On your test, when you're reading this, you got to highlight that important information, and you have to be able to pretty much use this in a lot of ways to reword everything. So, just like that. All right, let's describe our model. So again, the information that I, highlight that was important, notice I got that here too because that's going to help me explain my model a little bit. So notice that's my equation. And notice that I took my equation, my model, and I explained it. Notice I just didn't give it to you. I explained it. So I wrote, our model predicts for every person ahead of Ernesto there's an additional 2 minutes and 30 seconds it takes for him to get front of the line. Again, the information I took, important information, that's the explanatory piece that you're going to be using in talking about the correlation relationship. And you're doing it again, talking about the model that we have, but in particular the slope. Where did I get 2 minutes and 30 seconds from? Because I'm dealing with minutes, I have to talk about minutes. I just added seconds because that's what I wanted to do. You could leave it as 2 minutes if you wanted to. That depends on you. So, getting back to this, 2 minutes. Because again, that's the situation I have in my slope. It's 2, and because I'm dealing with time, that's dealing with minutes. And also, that's just the information I'm looking at. So M, and if you want to go further, it's just Y over X. So the Y is the minutes from the get to the front over number of people. All right. That is why I write it the way that I do. And again, when you're doing these report writing, you have to think of the situation you're given. Maybe I could talk about years, but in this I'm talking about minutes. So your answer has to reflect this information that you pulled out. All right. All right. Again, do you not notice? Do you not see the pattern? Because this important information, I'm taking that. That's my explanatory piece, and that's all I'm doing. Pretty much using that same statement, but writing it in multiple ways. All right. So if 10 people are in front of Ernesto, how many minutes does it take for him? I don't know why I wrote home, but him being Ernesto, for him to get to the front of the line. And again, this information that I pulled, that's going to help me analyze what's going on. So again, which one's X, which one's Y? So X is the number of people that was ahead of him, and Y is about the minutes that it took for him to get in front of that line. So let's read the question again, and let's decide which one is it talking about. Is it talking about my X, being the people in front of him, or is it talking about my Y, talking about how many minutes it took for him to get in front of the line? So let's reread the question. If 10 people are in front of Ernesto, how many minutes does it take for him to get to the front of the line? So what do you got? What's your given? You got 10 people, right? So it comes to people, that's going to be my X or my Y. So that's going to be my X, because it's talking about the people. So of course you are given using this formula Y equals MX plus B. And in this case, X equals my 10. So let's see what I did. Exactly like that. So again, this information comes from decimals, but I substituted X. So what I mean by substitution, I multiply this by 10. So 2.302 thousandths times 10 minus 5 and 132 thousandths. That should equal 17 if you don't want to round, but if you round up, 18 minutes. Because again, the situation is asking me about minutes. in which we understood for that to be y. And so we now know y equals that. All right. So you see how I write the statement? So now I just took the question and I just reworded it in form of answer. I'm gonna predict that if 10 people are in front of Ernesto, it would take him 17 to 18 minutes to get to be in front of the line or to the front of the line. That's fine. My statement's okay. It's just I misspelled Ernesto, forgot the O, and the R was not needed. So our model predicts that if 10 people are in front of Ernesto, it would take him 17 to 18 minutes to the front of the line, or to be in front of the line, or to get into front of the line. Again, this is just an example of how you could answer that question. You could reword it, you could reword the question and just put the number there. It depends on you. All right. Again, I take the information. Now, if it takes 10 minutes for Ernesto to move to the front of the line, how many people are in front of him? So now I gotta find X because I already given my Y, because Y was dealing with the minutes. So now we gotta go ahead and address that. And to do that, these are the steps I did. Again, because I knew I had to solve for X. So I said about this. So what I did, I added 5 and 132 thousandths to my left hand side. That's what I did. And once I added that and got that, then I divided, and this is the answer I got. And this is my statement. I'm gonna predict that if it takes 10 minutes for Ernesto to move in front of the line, there are 6 people in front of him, or will be in front of him, since we're talking about predicting. And that's essentially all you have to do, y'all. Just that.